In this lecture, we are going to explore the amazing world of proteins. Let's have a look at the lecture roadmap. On slide 2, you will see the list of learning outcomes. The purpose of learning outcomes for you as a student is to allow you to focus on what you need to learn in this lecture. Slide 3 puts proteins in context when it comes to disease. On slide 4, you will see an amino acid sequence of one of my favorite proteins. Please note you do not have to learn off this sequence. As we move on into the lecture then, we will have a look at the structure of the basic building block of proteins, which is the amino acid. We will go on then to explore how these amino acids string together and form a protein. We will explore the different structures that are found in proteins and how these relate to function. We then go on to look at a very important modification of a protein. This is referred to as a post-translational modification and involves the attachment of an entity to the protein. This change in the protein structure affects its function. We then have a look at what is meant by protein activity and wrap up the lecture in slides 33 to 35 by having a little bit more context for you. So we see here on slide 5 the basic structure of an amino acid. All amino acids have this particular structure in that each amino acid has a carboxyl group and an amino group. So the amino group is our NH2, so nitrogen and 2 hydrogens, and this is our carboxyl group here. What makes each amino acid unique and different is the attachment of this side chain, which is depicted here as the letter OR. Each amino acid has a unique side chain, and we see here on slide 6 that the amino acids can be classified into a number of different descriptions. As part of your homework then, I wish you to take the notes from the lecture and list the amino acids in each category. What I mean by that is I wish you to know what the small amino acids are, the branched amino acids are, and so on. It might be useful to generate a table. What I would also like you to note as you are doing this is if the amino acid has a charge or not, and is the amino acid hydrophobic or not. We see here then on slide 24 some examples of proteins, and all will be revealed with regards to the structure and what is meant by an alpha helix and a beta sheet. I would like to draw your attention in particular to this beautiful electron micrograph of collagen, where we have beautiful filaments or threads of collagen lying across each other. And it is a marvelous example of a pure alpha helical structure in a protein. Collagen is really important as a protein in the body, and you will come across it again and again as you go through the course. So for some more homework for you, what I would like you to do is to look up the amino acid sequence of your favorite protein. I want you to see if you can find the structure of your protein. And if you can do that, can you identify any structural features? What I mean by that is, do they tell you anything about the alpha helical or beta sheet content within the protein? And can you then identify the function of your protein? We see here then, as we move on into the lecture and as we're coming towards the end, on slide 30, the list of post-translational modifications of proteins. We will spend some time here looking at the different types of modifications that can happen to a protein. So we will focus in on these, and again you will see these post-translational modifications again and again as you go through the course. In particular, we will have a look at phosphorylation and what that means, and we'll have a look at glycosylation. And we have already come across the idea of linking a sugar to a protein in the carbohydrate lecture. So this wraps up the summary of this lecture, and I thank you for your attention.